Now we are discussing the electric field intensity due to two parallel infinitely long thin plane sheet of charge. I think in the last class I have discussed the difference in the thin sheet and thick sheet, and we have discussed the expression also. If it is thin sheet, all of you know we have to say sigma by 2 epsilon naught. If it is thick sheet, you will say sigma by epsilon naught. Okay. There are two thin sheets. Charge density is given sigma 1 and sigma 2 such that the sigma 1 is greater than sigma 2. We have to calculate the electric field in the region 1, region 2 and region 3. If I say this is plate A and this is plate B, one thing is clear that if I ask you electric field due to plate A, what you will say? Sigma 1 by 2 epsilon naught. And electric field due to the plate B, you will say sigma 2 by 2 epsilon naught. Again I am repeating, if question come for the thick sheet, then you will say it is sigma 1 by epsilon naught, it is sigma 2 by epsilon naught. Reason 1, where I have to calculate the electric field. Suppose I take this point. It is positive charge, so this is the direction of the EA, because wherever we want to calculate the electric field, we put the plus 1 charge there. This is also positive charge, so EB is also this. Then here also in this region, EA will be rightward because positive will repel positive. EB will also rightward. In this region, this is positive charge, positive will repel the positive, this is EA. This is positive charge, this is EB. It means if you add it factorially, here EA plus EB, here sigma 1 is greater than sigma 2, so EA minus EB, and here also EA plus EB. Now, whole thing I am showing in the next slide. Like, if I say I want to observe the electric field due to this plate, all of you know it should be away from the positive charge. Solve the reason. We are taking this second sheet, sigma 2, electric field again away from this. Now all of you can say in the region 1, E1 and E2 both are in same direction. In between the plate, E1 and E2 both are opposite. So this is the direction of the net electric field. And now I am writing all the values which we have discussed. There may be possibility that sigma 1 is equal to sigma 2. Then in between there will be no electric field. There may be possibility that sigma 2 is negatively charged. Then outside the plate in the region 1, region 3, there will be no electric field. Like this. If I say next situation, this is plate 1, this is the electric field due to the plate 1, away from the plate. This is negative charge. All of you know electric field will be towards the plate. Again we say we take the region 1, and if sigma 1 is greater than sigma 2, all of you will say direction is towards leftward. In region 2 also, in region 3 also. Now you first write yourself the expression. Yes. Again I am repeating, if sigma 1 equal to sigma 2, then there is no electric field in the region 1 and region 3. I hope it is clear to you. Now we will discuss the electric field due to the large uniformly charged metal sheet. Last expression we have discussed for the non-conducting sheet, and I think all of you agree our expression was sigma by 2 epsilon naught. What is the difference in the non-conducting sheet and conducting sheet? I hope it is visible with the help of the diagram. All of you know, in case of the metal, charges are repelled with each other, so they will appear on the outer surface of the conductor. So here charges will appear on the front as well as rear surface of the sheet. That's why we have both the surfaces having surface charge density sigma. So I hope the difference is very much clear to all of you. Now if you are interested to calculate the electric field at any point P, again you have to make the imaginary Gaussian surface like this. Please don't mind this line. This surface can penetrate, and sometimes you can think in this way also. You take the cylindrical Gaussian surface up to this. Then if I say there are three regions, first I am explaining this part 1, 2 and 3. I hope one is this plane part, third is this plane part, and second is this curved part. Now electric field. Direction of the electric field is everywhere here. Either is first part, second part, third there is no electric field. Inside the metal, no electric field. Area vector this, here this is the area vector. Now I write the Gauss law. Integration E dot ds equal to q by epsilon naught. E dot ds for first region, E dot ds for second region, E dot ds for third region, q by epsilon naught. In the first region, I hope it is clear to all of you, theta equal to 0 degree. Second region, theta is 90 degree. Third region, electric field is 0. So I hope only this first will be utilized. You will say E ds. Suppose I say this cross section area is S. Then I can say it is E dot S. Let me write on the next line. I think there is some trouble in this pen. E dot S equal to, what is Q? If sigma is surface charge density, then we have to say only with this part of the charge we are counting. So it will be sigma into S upon epsilon naught. We are getting E equal to sigma by epsilon naught. Now we can think from this diagram also. What I will say. Again there are three surfaces, 1, 2, 3. Let me change the color so that you will get better idea. Again here, this is the direction of the electric field. For the second also, this is the direction of the electric field. For third, this is the direction of the electric field. Area vector. This is area vector. Here, this is area vector. Here, this is area vector. All of intelligent at the second 90-degree angle. There is no flux there. And this first and third can be sum up. And what we write? I am writing directly E into S plus E into S. What is the value of the Q here? Yes, there are two surfaces. I hope it is visible to all of you. There are two surfaces, right? So you will say sigma into 2s upon epsilon naught. Now again you calculate this, you will get this expression E equal to sigma by epsilon naught. And I think I have discussed it many times. If any metallic body, an electric field surrounding is given by sigma by epsilon naught. Let me show it like this. You may think in this way also, in some numericals like this. So Same expression, sometimes you will think in this way, some numericals as I am telling you. One metal sheet is equivalent to the combination of two non-conducting sheets like this with same surface charge density. Okay, one more important concept is the electric field in the vicinity of a charged conductor. I think I have discussed many times. If it is a metallic body, you have to think somewhere you have to use the sigma word, and just outside we have discussed, on the surface we have discussed sigma by epsilon naught. All of you know, suppose I say this is metallic body, charge is always distributed on the outer surface such that surface charge density is inversely proportional to local radius of curvature at that point. So where is the sharp end, charges is more compared to flat end. Now I am showing you this. Let me explain first this. If there is a गेट बंद कर जाएगी ना, कुंदा लगा जो, कुंदा लगा जो। ट्रेन के पता नहीं। Suppose I say there is a point P where I have to calculate the electric field. We assume imaginary Gaussian surface. Suppose I assume this is imaginary Gaussian cylinder. I think there are three regions. Region 1, curved surface, then region 3. Now you think yourself, direction of the electric field, direction of the area vector. It will be like this. In bottom one, we all of you know inside the conductor electric field is 0. On the top one, direction of the area vector and direction of the electric field vector both are parallel, and on the curved part area vector and electric field vector are perpendicular. So again only one part you are supposed to use because you know Gauss law, E dot ds. I am not writing vector everywhere, but you have to take the mark, you are supposed to put it. Three region, but only top region is responsible, so I am writing only for the top region. E everywhere theta is 0 into ds, q sigma is surface charge density, ds region upon epsilon naught. What we get? E equal to sigma by epsilon naught. And I am telling you it is very important because we have derived it many times in different situations also. Just you pause the video and you just go through these slides. And finally, what we say, at any point just outside a charged metal surface, irrespective of the shape of the surface, net electric field is sigma by epsilon naught that we have discussed for the metallic cylinder, metallic sphere, and here for the random shaped body also. I hope it is clear to all of you. Thank you. Okay, these numericals I will discuss in the next video, so please go through that also. Thank you very much.